Hey, welcome back for part two. Hopefully you had some fun with your calculator there. You got a shape that looks like this. What this bottom thing is a pretty important first time we've done this in calculus. It's kind of like the number line uh, that we talked about in functions class that helped us figure out where functions had certain values, whether they were positive or negative, in order to solve inequalities. Very similar process, except for this is going to help us understand where a function is, um, the position and velocity, and it's going to help us analyze the motion. Of course, with a graph like that, it's pretty easy to see where it's zero. It's zero here, it's zero right there, it's zero right there. Notice that if we really wanted to, we could calculate the zeros because we know the function, right? The function was t cubed. What was the function? T cubed. Got to look it up. Got to look it up. Come on. Yeah, I know you're screaming at me. Just hold on. T cubed minus 13. I guess I could have just flipped it back, right? 13 squared um, plus 40t, right? This is the position function. And if I wanted to find the zeros, I could just set this equal to 0 and solve it, right? Advanced function stuff. But now, if I'm just looking at the number line, I can see in here that the function is negative. All the way in here, it's always positive, 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 positive. Here it's negative, and here it's positive. So what does this sign chart tell me? Well, it tells me that before 0 seconds, the object, the particle, was in a negative direction, probably to the left if we're talking about left and right. Here it was to the right, here it was to the left, and here it was to the right again. So that's what the notes are all about here. So if S is greater than 0, the object is in a positive position. Usually we think of positive as right or up. If it's 0, we're at the origin. So this idea of it started at the origin and then maybe the particle went to the right for a few seconds, and then a few seconds later, back at, what is that, 5 seconds. So at 0 seconds it was there, then at, looks like at 2 seconds it was there, and then again at 5 seconds it was back where it started. Then it went a little bit more to the left, and then it turned around again. And this sort of thing, we'll see an example of that soon. So don't copy that down. Don't have to copy that down. Of course, then if S is less than 0, the object is in the negative position. You know, either down compared to the origin or left compared to the origin. We talked about that. Moving on with the velocity function, you see the values I got, and notice I took the derivative, and I actually found where it was 0, so I could get that exactly. Maybe you did that on Desmos. So here, the velocity, we're talking about the velocity now. The velocity is 0 here and 0 here at 6 2/3. But otherwise, it was positive for these values, negative for these values, and positive for these values. So what does that mean? Well, the first derivative, velocity being positive, then negative, then positive. Well, a positive first derivative, the velocity being positive, the rate of change is positive. That means the position would be increasing. The position would be increasing, and it's moving in a positive direction. So that means it's probably moving to the right. We can see that, right? From 0 to about 2 seconds, from 0 to about 2 seconds, the position was increasing, right? You can see that. It's going up. First derivative is positive. And then right there, that's when the velocity was 0. So what happened when the velocity was 0? Well, the position reached a maximum, and the darn thing had stopped, right? It stopped moving. Similarly, when the velocity is negative, that's like it's moving left. It's moving back towards the origin, right? It's moving back towards the origin. And again, the position being 0, is at the origin, but the velocity being 0 is when it stopped. This is going to be a task for us to keep this straight, by the way. Okay, what's next? Acceleration. I took the derivative and acceleration, and you've filled in this, hopefully. The acceleration, when is it positive? Well, it's 0 right there at 4 1/3. I calculated that. It's 0 there, but on the left of that, it's negative. Negative acceleration over here, positive acceleration over there. And what does that mean with respect to the particle? Well, when the acceleration was positive, what that means is the pull. The particle was being pulled in a positive direction. It was being pulled right. We might be thinking that that means the acceleration is speeding up, but that's not true, and we'll see that soon. Something else has to be true for a positive acceleration to also mean that we're speeding up. So, for instance, it would make sense, right? If the object's being pulled to the right, but you're actually moving left, pulled to the right, moving left, it's like the acceleration and the velocity are fighting against each other. It actually would be slowing down, and that's what the end of this investigation is supposed to be. Acceleration equals 0, no acceleration, the velocity is constant. The acceleration less than 0 means the pull is in the negative direction. And some people think a negative acceleration means it's slowing down, but that's not true. If the velocity is left and the pull is left, so if you're already moving left and you're accelerating left, that means you're speeding up, right? So that kind of gives away the end of the investigation here, where if the velocity and the acceleration have the same sign, this particle speeds up. If the velocity and the acceleration have opposite sign, the particle slows down. And this sort of analysis allows us to completely analyze an object's motion. Just from the position function, we can tell everything about it. And we're going to have an example or two like that. Here's an example. So this is a position function. It says find the velocity and acceleration functions. No problem. The velocity is just the first derivative, and I'm just going to write it down there because this one's easy peasy. 6t squared minus 42t plus 60. Good old polynomial functions. No product rule, no quotient rules. Awesome. Acceleration, then, remember, is the derivative of the velocity, or the second derivative of the position. So I just got to take the derivative of that thing, which is, again, easy peasy. We love the polynomial functions. And then calculate and interpret these things. So s at 2, I just put 2 into my original function there. S at 2, and I'm going to put my interpretation right next to it and plunk that into a calculator. Let me find my calculated values. 52. Stupid telemarketer. Okay. S at 2 is 52, means the particle, the part, was 52 centimeters or meters or whatever it was, right. And velocity at 2, just substitute that in again, is 6 times 2 squared minus 42 times 2 plus 60 is 0. So what does that mean? When the velocity is 0, it means it was stopped, right? Velocity is 0 probably means it's either a maximum or a minimum, right? Maximum or minimum distance, position. The acceleration is which is equal to negative 18. And so that means it's being pulled, or the acceleration, the pull was left. Right? Left. And that's at 18 centimeters per second squared. That's the acceleration. Okay, dandy. Example 2, fast example here. Um, Consider the graph of y equals st given to the right, showing the motion of an object moving in a straight line. When is the velocity 0? Well, one of the ways to do this is to think of, is to think of the sign chart. Could have used a ruler. Where's the velocity? Well, I see it's positive here, right? It's increasing. The distance is increasing, so the velocity is positive. And right there is where I get my horizontal tangent, right there. So that's where it's 0. And again there, negative and decreasing here and then increasing after. When is the velocity 0? At time equals 2. When time equals 2-ish and 4. When is the object moving in the positive direction? Well, all we have to do is read it off of our sign chart now. It's when t is in this interval, the interval 0 to 2, but also from set union, from 4 on. When is the object moving in the negative direction? Well, in between those. And it's funny, in advanced functions, we had a notion of this because we could look at the graph, but now we've got a calculation. We don't have the equation of this one, but we do have a calculation that will back this up. This is the object moving in the positive direction. That's when the velocity is greater than 0. This is when the velocity is less than 0. And all we have to do is think about the function either in graph form or, as we'll see soon, and more importantly, in equation form. So in this one, we don't have a graph. We're going to do all this from scratch, and I'm going to do that in part 3.